Alright, let's look at another stoichiometry problem. This one's talking about, alright, we have an equation of propane with burning in oxygen to make carbon dioxide and water. Our numbers are still coming in the balanced equation, still talking about moles. Moles of one thing relates to the other using the coefficients from our balanced equation. But now we're starting with 20 grams of oxygen. That's fine. We have 20 grams of oxygen. We always put what we're given in the question on the top left of our dimensional analysis chart. But now note the question is looking for how much, which implies grams. They don't specify how much means grams. How much carbon dioxide or CO2 we can get. We have to cancel the unit we don't want. So grams of O2, whatever's in the top left, must always go down to the bottom right of our next piece. Grams of O2. Well, what can we turn grams into, you say? Grams of O2, well, we can turn grams of anything into moles of that same thing. Let's turn the grams of O2 into moles of O2. Now, if we're looking for the molar mass, moles per gram, or grams per mole, rather, we can find the molar mass of any compound on the periodic table. So we know that 2 oxygens would be 16 times 2, or 32 grams of oxygen. That's how much 1 mole of oxygen would weigh. The top and bottom are equal. They have to be in all these problems. Okay, so grams of oxygen are gone. Grams of oxygen divided by grams of oxygen equals 1. They cancel out. Cool. We're in moles of oxygen now. However, the question's not looking for moles of oxygen. It's looking for grams of carbon dioxide. So we have to keep going. We have moles of oxygen. We don't want that. So we take that unit, bring it down to the right, cancel that one. Now for moles of O2, we could go back to grams of O2, but that's not going to help us get forward or closer to our goal of what they're looking for. It's going to take us farther from grams of carbon dioxide. But we know with our balanced equation, we can go from moles of one thing in this equation to moles of anything else using the coefficients. So if they want grams of carbon dioxide, we can first go to moles of carbon dioxide, or CO2. Note, if we change the O2 to CO2, we can't change the moles. Only one of the units, either the moles can change, or the of something, the of CO2 or of O2. One of those can change, never both. Now if we have a mole-to-mole ratio, or a mole sandwich, we say, all right, there's 5 moles of oxygen needed for every 3 moles of CO2. There's water to be a 4. Again, moles of O2 cancel, moles of O2 cancel again. And we're in moles of CO2. Cool. But the question is asking for how much in grams. So we're not quite done yet. We have to cancel our moles of CO2 and go to grams of CO2, right? Just like we went from moles to grams in this first step, we can also go from grams to moles, rather, we can go from moles to grams this way. Now again, we have moles on one side and grams on the other, so there's only 1 mole in this fraction, means it gets a 1. The molar mass in grams of CO2, add up 1 carbon from the periodic table, so 12.01, plus 2 oxygens at 16 gets us 44.01. All right, moles of CO2 cancel. We're in grams of CO2, which is exactly what the question wants. So we stop our stoichiometry and do the math. Take our 20 times 3, because it's on top. It's a really bad time symbol. Times 3 times 44 divided by 5 divided by 32. We get 16.50 grams of CO2. That's how much CO2 can be made when we have 20 grams of oxygen and excess propane. That excess propane means we've got lots and lots and lots of it. There's no way we're going to run out of propane before we run out of oxygen. Oxygen is going to be what we call our limiting reactant. It's going to limit how much of our product, in this case carbon dioxide or water, we could make. So when they say excess propane, to a chemist it's really important. To you guys, it's kind of like extra information. Just means you got a lot of it. Don't worry about it. It won't be involved in the math of the problem.